Hello, in this video I'll be covering your number set theory and probability test review for Math 2. For number 1, you are asked to find probabilities when rolling a 6-sided die. Recall that the outcomes of rolling a die are that you can either roll a 1, a 2, a 3, a 4, a 5, or a 6. The probability of rolling a 2, there is only one 2. So it was 1 out of 6 possible outcomes. B, rolling an odd number. There are 3 odd numbers. 1, 3, and 5 are odd. So 3 of the outcomes are odd out of 6 possible outcomes. Next, you're asked of rolling a number that is a 3 and even. So if you think about a Venn diagram where you had 3 and even numbers, if this was the number 3 and this was the number even, there would be nothing in common. Sorry, it's hard to see. There would be nothing in common because a 3 is odd. So you cannot roll a number that is both a 3 and an even, so the probability is 0. Rolling anything but a 5, a 1, a 2, or 3, a 4, or a 6 would be those desired outcomes. So there are 1, 2, 3, 4, 5 desired outcomes out of 6 total possible outcomes. So 5 out of 6. Next, number 2 says Briley flipped a coin 6 times and got the following results. Tails, heads, heads, tails, tails, tails. This question is asking you to make sure you can differentiate between theoretical probability and experimental probability. If you think back to the lesson where we did the simulation of flipping a coin, the theoretical probability in theory means what should happen or what you expect to happen. What should happen. That's in theory. In theory, every time I flip a coin, I've got a 50% chance of getting a heads and a 50% chance of getting a tails. So the probability of flipping a tails is 50% or 1/2. That's in theory. However, if I flip a coin multiple times, that does not mean that half the time I'm going to get a tails and half the time I could get a heads. So the experimental is analyzing the actual outcome of an experiment. So if I were to conduct an experiment of flipping a coin 6 times, I actually got a tails 1, 2, 3, 4 times. So my experimental probability is based off of the actual outcomes of an experiment, while the theoretical probability is based on what should happen in theory. That half the time I should get a heads and half the time I should get a tails because I have 2 possible outcomes that are equally likely. Part C asks, what is the probability of flipping tails on the 7th trial? Well, 7th trial, my outcomes are a head or tails. So consider that. All I can get is a head or a tails. If I want to know the probability of flipping a tails, it's 1 out of the 2 possible outcomes. So it's just 1/2. Next, for number 3, it says Jalen is buying a pair of new shoes. He needs to choose a brand and a color. And he has 3 different brands to choose from and 3 different colors. So if you consider that, 3 times 3, 3 brands and 3 colors, there are 9 possible options he has, and you are asked to draw a tree diagram to illustrate his choices. Remember that for a tree diagram, we need to see 1 tree. So he has this right here, these 3 branches represent his first choice, which is what brand he's going to choose. So he can choose from Nike, Adidas, or Jordans. Once he makes that choice, he then has 3 options. He can choose black, white, or red. So I'm just going to use the first letter, B, W, R. But he could choose those in every single brand, black, white, or red. Black, white, or red. And that would be your tree diagram. The sample space is a list, meaning the outcomes separated by commas that begin with a brace and end with a brace. That's in your definition for your vocabulary for this unit. So Jalen could have picked Nikes that are black, so I'm going to use NB to represent that. Nikes that are black, Nikes that are white, Nikes that are red. On this next branch, he could have chosen Adidas that are black, Adidas that are white, or Adidas that are red. And lastly, he could have picked Jordans that are black, Jordans that are white, and Jordans that are red. So there are, if you count the number of leaves on the tree, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9. Same as if we had multiplied his number of choices for each decision. So he had 3 brands to choose from and 3 colors he could choose from. That's 9 options. That tells you that when you list your sample space, you should have 1, 2, 3, 4, 5, 6, 7, 8, 9 elements in your sample space. Next, we are asked to determine some probabilities based on this information. So for part C, what's the probability that he chooses Jordans that are white? Jordans that are white is only one option out of the 9 total possible options. For D, what's the probability that he chooses shoes that are black? Well, 1, 2, 3 options were black, or you can look in your sample space. Nike's black, Adidas black, Jordan's black. That's 3 out of the 9 possible options were black. And lastly, what is the probability that he chooses Nike or Adidas? Well, there are 1, 2, 3, 4, 5, 6 options that are Nike or Adidas. So 6 out of the 9 options would be the probability. On the next page, or on the right side of your page, you are asked to find some probabilities based off this frequency table. On this frequency table, you have headers of giving CPR and not giving CPR as a cause of death, and plane crash and car crash as a cause of death. So, how we would interpret this is we know that there are 163 total deaths represented in this frequency table. At the intersection of a header on the side and above would mean the frequency of somebody dying by a plane crash while they were also given CPR. So that's what the 7 represents. At the end, these are our totals. So this means 28 people died from a plane crash, CPR and not given CPR included. So 7 plus 21 is 28. There were 135 people that died from a car crash, 54 people died that were given CPR, and 109 that died not given CPR. So we are first asked, what is the probability of not CPR or not given CPR? So that means we want to use our not CPR total. It doesn't mention anything at all about plane crash or car crash. So that means we need to use the total here to go on our numerator. So not given CPR is 109 out of the total of 163. Part B, death by plane crash. So that means only those that died by a plane crash. So we take our plane crash row, follow it all the way over here to the right. There were 28 people that died by plane crash out of 163 represented in the table. Next, we are asked no CPR, death by car. So that means we need to find the intersection of not CPR and death by car. So not CPR, death by car, that's 88. So 88 out of 163. So in this first table, we're just asking you to find probabilities and we're giving you the information. In this next one, we are giving you the information, asking you to create the table. It says Mr. Cannon surveyed 85 sophomores at South Central. He found that 48 sophomores play football and 12 of those also play baseball. There were 26 students surveyed that do not play either sport. So the big idea you need to catch on is that right here he surveyed 85 sophomores, and this table shows the results. So that 85 is going to go down here in our total. Out of those 85, 48 sophomores play football. So, football, total, 48 sophomores play football. Then you are told 12 of those also play baseball. So because it's in the same statement and it says, and 12 of those, that means 12 of these 48 also play baseball. And lastly, 26 students surveyed do not play either sport. So no baseball, no football, 26. It is now your job to complete the rest of the table. So we are going to use deductive reasoning, meaning we can figure out that, well, if we know a total is 48, and I know one part of that 48 is 12, to find the remaining amount, I would need to subtract. So if for any totals given, we're going to take the total and subtract out the value we know. So 48 subtract 12 is 36, and I'm going to fill that in here. I'm also given the total, so if I know of this total of 85, meaning these two numbers here add up to 85, 48 plus this number add up to 85, I can work backward and subtract. So 85 subtract 48 is 37. And I've got some options to go from here. I can do 36 plus 26 to get this total, and that gives me 62. And then I can also work backward again and do 37 subtract 26 to get baseball and no football. And that gives me 11. And then I can add 12 and 11 here for baseball to get the total for baseball. So 12 plus 11 is 23. Now, we know that our table should be accurate if I can total these numbers here, 48 plus 37, and I get the total of 85, as well as if I total the horizontal row. 23 plus 62 is also 85. So that should give us confidence that our values are correct. Next, for number 6, you are asked to create a Venn diagram to display this data. So we are first going to draw a box, a rectangle here, and put two circles that overlap. How do I know to do 2? Because it says that the survey found that 214 applied to ECU and 78 applied to NC State, and 52 applied to both schools. So that means one circle needs to represent those seniors that applied to ECU. The other circle needs to represent those that applied to NC State. And then I can fill in some information. So all these numbers are very important, and you need to do something with all of them. However, you've got to pay attention. Sometimes you'll just do some math. So it says 214 applied to ECU. Do not put this inside of the circle. The total here for ECU is 214. 78 applied to NC State. These are category totals. You do not put them in the circle. We use this next bit of information, that 52 applied to both schools, to show that 52 students applied to both ECU and NC State. Now, we need to take our ECU total of 214 and subtract the 52 to get those that applied to ECU only. So in my calculator, I'm going to type 214 minus 52 to get 162, and that gives me the number of students that applied to ECU only. So these two numbers should add up to the total. Do not take all the numbers in the problem and just put them on the table. That would be incorrect. To find the number of students that applied to only NC State, I take this 78 and subtract out the 52, leaving me with 26. So again, these two numbers should add up to 78 students applying to NC State. The last number you need is using this fact that 422 seniors were surveyed. Not all of them applied to college. So I need to take this total of 422 surveyed and subtract out all the numbers in my Venn diagram. The 162 that applied to ECU only, the 52 that applied to both schools, and the 26 that applied to NC State only. And that leaves me with 182. And that means that our Venn diagram is complete. One way you can check to be sure you've included everything, 182 plus 162 plus 52 plus 26 adds up to the 422 seniors that were surveyed. So make sure the sum of all your numbers gives you the total. All right, in the next video, I'll cover the back of the page.